This video is going to be a detailed video of the features of the talus, one of the 7 tarsal bones. I have 2 here. This is a left talus, and you can tell that by the direction of the head. Here's the head of the talus, and it should be directed medially. The other way that you can tell is the lateral facet here for the fibula is large for the lateral malleolus compared to the medial facet for articulation with the medial malleolus. So this is a right talus. Notice the head is directed medially. And then if we look at the lateral side, there's a large lateral facet for articulation with the lateral malleolus of the fibula compared to the medial side that has a smaller, like comma-shaped facet for the medial malleolus. If we look at the superior aspect, we can see the trochlea, which I'm outlining, or the dome of the talus. That's for articulation with the tibia. And notice that it's wider anteriorly than it is posteriorly. So when the foot is dorsiflexing on the fixed leg, the convex talus, a convex dome or convex trochlea rolls and glides posteriorly on the concave mortise, and the larger, wider anterior part of the trochlea wedges into the mortise. I had already pointed out the comma-shaped smaller facet on the medial side for the medial malleolus of the tibia, and then on the lateral side a much larger lateral facet for articulation with the lateral malleolus of the fibula. If we notice on the neck here, the multiple foramina, those are for the blood supply to the talus. The talus is unique because there are no muscles that attach to the talus. Much of the talus is covered with articular cartilage. So we already pointed out the trochlea and this medial facet, and then the lateral facet, all covered with articular cartilage. If we look at the inferior aspect, this posterior facet for the calcaneus is covered with articular cartilage. This is the middle and anterior facets for the calcaneus, covered with articular cartilage, and then the head of the talus is covered with articular cartilage. So most of the talus, a large percentage of the talus, is covered with articular cartilage. It is one of the bones that's susceptible to avascular necrosis due to disruption of blood supply. Won't we look at the inferior aspect again and look at the 3 facets of the talus that articulate with the calcaneus to make the subtalar joint. So posteriorly, we see this very large concave facet, posterior facet for the calcaneus. That's the posterior part of the subtalar joint. And then the 2 smaller anteriorly positioned facets, the middle facet and the anterior facet. Quite frequently, these are one continuous facet, but these are convex and are for articulation with the calcaneus, the middle and anterior facets of the calcaneus. I have a calcaneus here. Let me just make sure. I'm going to get a left calcaneus. Yep. So here's the superior view of the calcaneus. This is the posterior facet that's convex that articulates with that posterior concave facet of the talus. There they are articulating. That's the posterior part of the subtalar joint. And then here's the middle and anterior facet, much smaller anterior facet on this specimen. And notice they're continuous with each other. Large percentage of these 2 facets, or large percent of individuals, these 2 facets are continuous with each other. So if we put the talus on the calcaneus, we can see them articulating with each other. This middle facet on the calcaneus is on the superior surface of the sustentaculum tali. So we can see when we articulate that sustentaculum tali is supporting part of the head of the talus. Now let's look at the inferior surface again, or inferior aspect, and you notice the space between the posterior facet and the middle and anterior facets. This is the sulcus tali, or talar sulcus. And notice that on the medial side, if you notice, this is the medial side because we see that smaller medial facet. On the medial side it's narrow, On the medial side it's narrow and then it widens here. This, when the talus and calcaneus articulate with each other, this sulcus tali matches up with the sulcus calcanei, and it creates the talar canal. If we look through there, the talar canal. The sulcus tali and the sulcus calcanei, when the two bones are articulating with each other, they create the talar canal. I have another foot that's articulating with each other that's wired together, might be easier to see. So that space, that hole that we see, will come from a posterior aspect. You can see the probe coming through. That's the talar canal. So once again, just to repeat, the sulcus tali and the calcaneal sulcus, when they come together and they form the talar canal. The large opening here, before you get to the talar canal, is the sinus tarsi, or the tarsal sinus. So attaching to the sulcus tali is the interosseous talocalcaneal ligament. It's a bilaminar or two-layered ligament, very strong, separating the anterior part of the subtalar joint from the posterior part of the subtalar joint. Also attached to the neck of the talus here is the cervical ligament. The cervical ligament is in the sinus tarsi, and it's anterior to the interosseous talocalcaneal ligament. Now let's look at the posterior process of the talus. This is the posterior process of the talus. And the posterior process of the talus has two tubercles, a larger lateral tubercle and a smaller medial tubercle. And between the two is a groove. That groove is for the tendon of the flexor hallucis longus. These two tubercles serve as a site of ligament attachment. Let's look at another talus that's maybe the tubercles are in a little bit better shape. Yeah, here we go. So here's the posterior process of the talus. This is the larger lateral tubercle of the posterior process of the talus, and this is the smaller medial tubercle of the posterior process of the talus. There's the groove for the flexor hallucis longus tendon. And when we have the calcaneus and the talus articulating with each other, you can see how that groove in the posterior process is continuous with the groove on the inferior surface of the calcaneus, specifically the sustentaculum tali. So the flexor hallucis longus tendon lies in this groove of the posterior process and then lies on the inferior surface of the sustentaculum tali of the calcaneus. These tubercles are for ligament attachment. The lateral tubercle of the posterior process of the talus is for the posterior talofibular ligament, part of the lateral collateral ligament of the talocrural joint or ankle joint. The medial tubercle of the posterior process is for the posterior tibiotalar ligament, part of the medial collateral ligament or the deltoid ligament of the ankle joint. Also attaching to the posterior tubercle are talocalcaneal ligaments. So this is the medial tubercle of the posterior process of the talus, and the medial talocalcaneal ligament attaches there. It goes from the medial tubercle of the posterior process of the talus to the sustentaculum tali of the calcaneus. It's almost horizontally oriented. Attaching to the posterior process of the talus is also the posterior talocalcaneal ligament that goes from the talus down to the calcaneus, and that's vertically oriented. The lateral talocalcaneal ligament attaches to the lateral process of the talus. So we saw this large lateral facet for the lateral malleolus. Here's the lateral process where the lateral talocalcaneal ligament attaches. So it goes from the talus here down to the calcaneus. Fractures of the lateral process of the talus are a commonly missed fracture that's mistaken for an ankle sprain. So be sensitive to that idea that this lateral process, can fracture with the same mechanism of injury as a lateral ankle sprain. The anterior tibiotalar ligament, or part of the lateral collateral ligament. The anterior talofibular ligament, or the ATFL, part of the lateral collateral ligament, and it's thin and wide and flat, and one of the most commonly torn ligaments, attaches from the anterior edge of the lateral malleolus to the lateral aspect of the neck of the talus. So, approximately here. So that would be about the approximate location of the ATFL, the anterior talofibular ligament, a flat, thin, and weak portion of the lateral collateral ligament. It blends with the capsule of the talocrural joint. So that's an important ligament to be aware of. Fracture of the lateral process of the talus is also commonly called snowboarder's ankle because of the increased incidence of this fracture as a result of snowboarding. It's the second most common fracture of the body of the talus, and fractures of the lateral process make up about 2.5% of all snowboarding injuries, according to a study done by Judd and Kim in 2002. Fracture of the lateral process of the talus can be one of those commonly missed fractures of the foot that is mistaken or misdiagnosed as a lateral ankle sprain. It could be an avulsion fracture from the lateral talocalcaneal ligament, which attaches here. This lateral process is also has been recently called a snowboarder's ankle. Well, the lateral process fracture has been called snowboarder's ankle because of the increased incidence of this fracture as a result of snowboarding. If the lateral tubercle of the posterior process of the talus is elongated, it's been called a stida process, S-T-I-E-D-A, stida process, and fractures of the lateral tubercle of the posterior process have been called Shepherd's fractures. And fracture of the lateral tubercle of the posterior process of the talus is one of the 5 most commonly missed fractures of the ankle and foot, again commonly misdiagnosed as a lateral ankle sprain. Sometimes there is an accessory bone here called the os trigonum. So the lateral process is a potential site of an accessory bone called the os trigonum or the trigonal process. The accessory bone can be variable in size and shape, round, oval, or triangular. And it's said to be present in about 2.5 to 14% of normal feet. What happens is the os trigonum results when the lateral tubercle ossifies from a secondary ossification center and doesn't completely fuse with the rest of the talus. The os trigonum can be completely separate from the rest of the talus, and they can articulate. The os trigonum can articulate with the talus, or it can be connected by fibrous tissue or ligamentous tissue, forming a synchondrosis. Posterior impingement syndrome or trigonum syndrome or talar compression syndrome can occur from prolonged plantar flexion, and it can cause impingement of the os trigonum.